So welcome to tonight's Tech Hour. It's Thursday, the 1st of December. Christmas is just 3 or 4 weeks away. And the title today is Less is More, Make Tech Small Again. And in some sense, the background to this is that my first computer, which I bought about 30 years ago, had 2 megabytes of RAM and 40 megabytes of storage and a 10 megahertz CPU. Nowadays, everything is measured in gigahertz CPUs, gigabytes of memory, and the lucky of us have a terabyte or two of hard disk, except it's not a hard disk, it's a solid state drive or better. So the situation now compared to when I started, or before that, when Don Knuth was developing tech, was very, very different to what we have now. And the culture of everything is very, very different. So one example of this is that tech doesn't have memory management. It doesn't have, well, it has limited garbage collection. It does reference garbage collection, I believe, for boxes and so forth. But the dictionaries, once you put something in a dictionary, the key to the dictionary is always there. It doesn't go away. There's no sort of resetting of memory. And these things were done pragmatically in the same way that Pascal was used pragmatically as everybody's second best language. And we have things now like Linux, and the latest hot new thing is Rust, which makes writing error-free code that manages memory much easier. And there's also functional programming, which by dint of hard work and research, now gives perfectly good performance, and it avoids all the problems associated with assignment of values and values not having the not storing what you expect them to do, and it also scales up nicely for multiprocessor machines. So these are just some examples of how everything has changed, but I think the biggest change is the mobile phone. Personal computing is now on your person, and when I was there, personal computing means you owned one of them, whereas now we have more than we need. And so the whole environment has changed. And one of the big game changers, I think, is the web browser and the network. So you can now run an experimental version of OpenOffice in your web browser, and it has acceptable performance. And it's, I think, a 300 megabyte download. It doesn't have to be downloaded every time you open it. It gets stored in local storage and then reused. And the installation of software shouldn't take a long time. And if I can run tech on a 40 megabyte machine with 2 megabytes of RAM, can't I download everything I need to run tech from a website and be up and going within 5 seconds? I ought to be able to emulate that experience I had that time ago today, without having to put in lots of floppy disks and everything else like that. I should be able to start using tech in 5 seconds. And I'm not talking about what they do in Overleaf, which is they have their servers running all the time, and your typesetting is actually done on Overleaf. I'm talking about being run in your own browser, which has got a large number of benefits. In particular, you don't need servers to host the thing, and you don't need a network connection to use it, which is quite good in some secure environments. So ever since about 1990, I've been sort of thinking about expanding the horizons of tech, and some of the early articles I wrote for Tugboat, the Tech User Group Journal, are about that. And I remember in something like 1995, was it? Something like that. I wrote a paper saying editable DVI files or WYSIWYG tech. It wasn't practical, but the idea was there. And the key idea there is that you don't lose any information in the typesetting process. So every word that gets typeset, you embed the source file in the output. And it's not a new idea. It's what any WYSIWYG system has to do. If you have a WYSIWYG system, then through the mouse and the cursor, you have to be able to access the underlying document. So the underlying document has to be available somewhere and has to be linked to what's displayed. And this is the stuff that Alan Kay in the 70s, I believe, pioneered with Smalltalk, which then became incorporated into the Apple Macintosh, for example. So I'm going to give a talk that's different from what I thought I was going to give. My title is Make TeX Small Again. My approach is going to be a bit different. I'm going to look at the essentials of tech. What are the essentials of tech? And then how can we prevent tech growing like it did before? How can we keep the essentials but not put in other things? And in one of the references, I quote Don Knuth as saying something to the effect of, all I want to do was write a typesetting language, and the things that macro programmers wanted to do, that users wanted to do so they could adapt to their particular purposes, I was most reluctant to put in, because all I wanted to do was write a typesetting program. So a typesetting program requires knowledge of typesetting, not just the current methods or then current methods, but also the underlying principles and the examples of what's good and what's not so good and so forth, and all the conventions. And that was one of the things that Don Knuth did a lot of studying about, and he met with typographers. He met with people who are experts in typography as a practical art. And this is book typography and journal typography. And I think the two things that really made tech succeed in the wider world was the involvement of the American Mathematical Society, which was a big entree into STEM publishing, and the involvement of Leslie Lamport, who's a first-class person, and his work in digital equipment on a documentation system, which very closely was based on TeX. And LaTeX grew out of Lamport's work in that area. Now, I'm not sure what I would identify the archive as something that's close to the AMS today, in that it's a major publisher of STEM, and even though it's not a developer of software, it's interested in the development of software, and it has the right ethos in the same way that the AMS had the right ethos. The equivalent of Leslie Lamport is probably not one person, but several. And I suspect people outside the LaTeX community or the tech community, when you say digital typography today, you probably mean typography on web pages. Most people will understand that to mean, oh, well, actually, what happens now, if you say typography, a lot of people will think of web typography first and book typography second. I don't know what the balance is. But if you talk about digital typography, you'll think about digital media, you'll think about web pages and that sort of thing, and you won't think about print typography. Oh, they'll say, that's PDF typography. That's not digital typography, because it's all concerned with paper and pages. So I'm going to focus on one part of the TeX system, which is chapter 14 of Donald Knuth's TeX book, whose title is How TeX Breaks Paragraphs into Lines. And in the old days of metal, you typeset the paragraphs and then you split, and the paragraphs would be in lines, and the lines would be moved from one page to another as you're making up the pages. And you might get errors such as the same line appearing twice, or lines getting put in the wrong way, but basically it was a straightforward process. When we start talking about accessibility and tagged PDF, when you're breaking the paragraph into lines and the lines into pages, you're actually breaking something, which is the flow of the text. And on a piece of paper, that's implicit by convention. You finish at the bottom right corner of one page and you start at the top left corner of the next page. And the visual signs provide the navigation. And there's an intelligent human being to do that. But when you're using a screen reader with a PDF document, it has to know how things are linked. And the classic thing in mathematics is you have a third plus a sixth equals a half, and your screen reader, just looking at the position of things, reads all the numerators, and then the fraction bars and the equals and the plus, and then the denominators. I don't know to what degree that actually happens, but it's certainly an indication of the problems you have. And with tables, you're never quite sure whether they're layout or meaningful. So another example, which still isn't solved in LaTeX, is if you've got material that is in color, if the foreground color, if the text is in color, you might say, okay, so we'll have a group that begins blue and ends blue and reverts to the usual font. And the normal way of handling this is to put items in the page that push and pop the color stack. But unfortunately, the push is happening on one page and the pop is happening on the other. And in PDF, the pages are supposed to be renderable separately. So when you break a paragraph into lines, in the modern view of things, you're actually breaking something. Something no longer works, which is the flow of text. And you have to maintain that flow of text. So that's a different context that did not exist in Don Knuth's time. Don Knuth did not have that problem. Don Knuth was making his books look as good as they were. They were originally typeset using hot metal with skilled mathematical typographers. And then a sort of hybrid, partially electronic, partially optical process was introduced, and it was horrible. And Don Knuth wrote a fully digital approach, which we call TeX, in response to that. So his objective was that the printed pages would read as well as they were before. And he wasn't concerned about web browsers, which was quite wise because they hadn't been invented at that time. But we are, and that's an important part of our context. Now, breaking a paragraph into lines is one of the key functions of a typesetting system. I'll read what Don Knuth says, because he's more believable than I am. One of a typesetting system's chief duties is to take a long sequence of words and break it into individual lines of the appropriate size. For example, every paragraph in this manual has been broken into lines that are 29 picas wide, but the author didn't have to worry about such details when he composed the manuscript. TeX chooses breakpoints in an interesting way that considers each paragraph in its entirety. So this allows TeX to, if you want to set it, you can have the paragraphs, and every paragraph not having white space at the end, but the last paragraph, last line of the paragraph somehow magically is exactly long enough to fill the space. It can look ahead. It's a very interesting piece of computer software. It's an algorithm that's important. I think it's called dynamic programming. And the crux of it is that it takes a problem that seems to involve an exponential amount of time, because the number of paths through a cube, the number of paths through the possible breakpoints is exponential as the paragraph gets larger. But the dynamic programming allows you to forget about breakpoints if there's a better path, if there's a path that is going to be better. And it's nice stuff, and it's very powerful. And Don Knuth regards that as one of the chief functions of a typesetting system. Now, most of us regard LaTeX as a typesetting system. And I suppose it is if you have the appropriate definition of typesetting. But LaTeX does not break a sequence of words into into lines for a paragraph. The purpose of the LaTeX macros in terms of paragraphs have got two functions or three functions. The first function is to put things in a horizontal sequence. So when you type the letter A in LaTeX, in your editor, and it goes to LaTeX, then most of the time, it creates the letter A in this horizontal list. And there's a bunch of things that can appear in a horizontal list. And TeX knows all of what they are. And LaTeX can't define any new types of thing to go into the horizontal list. The things that are admitted in that horizontal list are fixed, in the sense of it's a character in a font, it's a piece of glue, it's a kern, it's a penalty. These are the things that can appear in a horizontal list. And LaTeX's first responsibility is to put things into this horizontal list. And that deals with the changes of fonts, for example, and the sizes of fonts, and also includes the mathematics. So you get this horizontal list. The second duty LaTeX has is to determine what parameters for the line breaking to use. So 29 picas is the horizontal size, and there's also how expensive is it? What's the aesthetic penalty for a hyphen? What's the aesthetic penalty for two hyphens in a row? What's the aesthetic penalty for a line that's rather tight or a line that's rather loose? So there are all these penalties associated with things, and if you change the parameters, you get a different appearance. And there's also parameters that affect the glue at the left and right end of each paragraph. So if you want to, you could set a paragraph, and by changing the parameters, instead of being flush left and flush right, it could be ragged right, or it could be ragged left, or each line could be centered. And all this is a question of setting various paragraph settings. And there's even a paragraph setting that allows you to typeset in a circle. You just say, these are the lengths of the lines I want, typeset the thing into this shape. Now, LaTeX, which is a macro package, has macros that put things onto the horizontal list. And it decides what the paragraph settings are going to be. And it also, in some sense, decides when to ask TeX to break what it's got into lines in a paragraph. So take the long sequence of words and break it. And it does that by issuing the \par command, which is also issued whenever you have two blank lines, which is why you don't need to write it very often. And then TeX goes away and does one of its chief duties, which is to take a long sequence of words and break it up into individual lines. So the really important point I'm making here is that LaTeX has, or whatever your macro package is performing a really important function, which is putting things on that horizontal list. That's a really important function. But those things that are put onto the horizontal list, once they've been put on, are no longer macros. They are, what's the word? A list of restricted things, a list of things that TeX knows about for horizontal lists, and what can appear in that list is hard coded into TeX. And when TeX takes that paragraph, it uses the values of the parameters, the paragraph building parameters that LaTeX or whatever is given it, and TeX macros do not function at all during that crucial period. So you get TeX macros or LaTeX macros putting things on the horizontal list. Then you get the \par command, and the macro engine is shut down. It doesn't do anything. It's idle. It just stays where it is. And the typesetting functionality takes place to break the paragraph into lines. There's no to and fro between the two. It's put all the stuff in, ring the bell, and the typesetting system comes in, takes over the whole process, and when it's finished, it rings the bell again, and the macros can then resume. So that is the bare minimum of a typesetting system, or at least it's dealing with that essential function. So what else do we need? Well, we need to put things into the list, which means we need to know about styles, the rules for what size of fonts to use, the rules for paragraphs, the rules for the spaces between things, all that sort of stuff. And that's the sort of stuff that LaTeX does. And it does it with two inputs. The one is the author's source file, and the other is the style files it has. And that's the TeX macro programming. And it's the same sort of thing when you write /def my macro or my name or new command if you do it the LaTeX way. You're producing a system that translates those various inputs into commands that are typesetting commands that put things onto a horizontal list. And there's no reason at all why some other system shouldn't do that. So the interface for feeding TeX, for putting things onto the horizontal list, can again have a very restricted vocabulary that corresponds quite tightly to what TeX understands. And the rest is dealt with by another system that TeX doesn't know about. It's just another system that is written in whichever language you'll find most convenient. So if you're using Markdown, you use your own translator from Markdown to LaTeX. Nobody now would ever write a Markdown interpreter, Markdown parser using LaTeX or using TeX. And I would say that LaTeX is a markup language. We have to ask, yes, use LaTeX as a markup language because lots of people are familiar with it, but there are not lots of people that are familiar with writing style files and so forth thoroughly and carefully and so forth. And it's got a number of problems, particularly for verbatim. So why not implement the macro side of LaTeX in something other than TeX macros? And historically, we always implement these things using TeX macros, but it's not always the case. And even, Don Knuth, when he had complicated input files, which he called web, the literate programming system, he didn't write macros to interpret web documents. He wrote separate programs, Weave and Tangle, for interpreting web documents. And I can't remember which one, Weave, I think, takes the source and translates it into pretty low-level plain TeX, which is then fed to do the typesetting. And there's no reason in principle why LaTeX documents should not be processed in the same way. And if you do that, then you have the benefit of saying, oh, we're processing this LaTeX document in this way to produce TeX output, but while we're at it, we'll produce some XML and HTML output at the same time. So that's one area. By saying creating paragraphs is the key thing. Why do we need to, all we need to do is provide an interface so that we can feed things in to put them on the horizontal list. Now, for typesetting, the paragraphs, after they've been broken into lines, are then by and large put onto the page. When the page gets full enough, when there's enough accumulated on the on the main vertical list, is sent out to make a page with. And again, there's no reason why some other process shouldn't do that. And that's exactly what Martin Ruckert's hint system does, which it sort of says, we're going to take the horizontal lists and make those the main output from the typesetting part. It splits TeX into two parts. The one is creating the horizontal lists. And then the second part is both breaking the paragraphs into lines and also turning the lines into the pages. And that allows him to create on-the-fly typesetting of documents in a ebook reader, where you have TeX typography, but as you change the dimensions of the page, so the typography, so the line breaks adjust. And again, with Martin's hint system, LaTeX macros do not appear in the browser, in the viewer side of things. They just don't exist, except in the form of there are parameters being set somewhere. Now, a good way of understanding the relationship between the two is what in HTML is called the non-breaking space. So the non-breaking space is really important. Let me think of it. Yes, when you have chapter 3, you'd like to keep the 3 next to the chapter, so the 3 isn't at the beginning of the next line. Or if it's dr dot Dr. Fine, if the dr dot appears by itself and then a line break, it's actually pretty horribly ambiguous, because is it the end of the sentence or isn't it? And so the non-breaking space is an HTML character, this Unicode character, which is like a space, but you're not allowed to put a line break there. And TeX implementation of a non-breaking space is simply, if I've got it right, it's a space followed by a penalty. You can put a penalty on a horizontal list, you can put a space on a horizontal list. If you put a space followed by a penalty on a horizontal list, it behaves like, and so we call it a non-breaking space. And that's that little tilde that you put in your source document. You probably remember being trained to do that. And the fact that the tilde character behaves in that way and it produces that output is all LaTeX macros or plain text macros, but the consequence of it is the typesetting side. So the purpose of LaTeX is to put the right things into the horizontal list and to set the parameters. I'm simplifying quite a lot. And the purpose of the typesetting is to break that long list of things into lines of the right length for whatever it is you're doing, 28 picas or whatever it is. So on the output side, you could have something like hint. In the 1990s, a company called Life Sciences, I think, and the name, Graham Asher, they produced something called PageTeX, which took the DVI output and repaginated it to give better outputs. The page makeup in TeX has always been a bit sort of not nicely done, and that was because of the memory constraints that TeX was running with at the time. That to do page makeup on a 50-page chapter requires a large amount of information to be readily available, and that requires more memory than most people could afford. So that's a case where a separation and allowing a separate program written by other people to do the page makeup is really very, very helpful. And the constraints of page makeup are so different because you don't want to change the content, and you are much more interested in saying, oh, well, the figures want this figure here, this figure here, this figure here. Let's see how the text flows. And so often, particularly if you're interested in quality, it's an interactive process. When I was working at the Open University, the print pages, the books we produced were quite nice, and they had what were called sewn signatures, and the signature had 16 pages. And there's a considerable benefit if you could save one page and thereby save a signature, because that means that you've actually saved 16 pages of the output rather than one page. So the hand process has some sense there, but it's certainly a different sort of thing. And it doesn't make sense in the context of web typography. When we look at a web page, and we call it a web page, we don't expect it to fill no more than the browser view. We expect to be able to scroll up, which is the old scrolls that sort of had a roller at the top and a roller at the bottom, or on side to side, that were used in ancient times, and that's what scrolling is. But we don't expect a web page to be broken up in this. A web page, the breaking up of a website into web pages is very different from the breaking up of a book into pages, a printed book into pages. And the page has got a completely different meaning. And I take that as an indication that pagination, if we're producing the output for the web, is an entirely different sort of matter than pagination if producing it for print. One of the great goals of print pagination is to make best use of the physical materials available and don't waste white, lots of wasted white space is expensive. Paper is expensive. So I haven't dealt with mathematics, but in this point of view, mathematics is pretty much the same as paragraphs. And inline mathematics, as opposed to the display mathematics, inline mathematics has got the same problem, that you can have line breaks inside inline mathematics. And advanced mathematicians speak in this strange language, which is a mixture of words and symbols and equations. And you might have quite a long equation inside the text of a paragraph, and you might have a line break inside that equation. And you might or might not have a page break separating one part of an equation from the next. And if you want somebody to read that paper from a tagged PDF, you've got to do a lot of work to keep everything going properly. So that's about where I've got to. And essentially my point of view today, as I've expressed it, is the essence of tech is putting things on a horizontal list, breaking it into pages, that sort of stuff, breaking it into lines. And all the other stuff doesn't have to be done using tech macros if you don't want to. But certainly putting things on the horizontal list and setting the paragraph parameters, that has to be done. So part of LaTeX has got a cross-reference system where you can it's got IDs and references. You can label an equation and get the equation numbering working, all that sort of stuff. And that sort of stuff should work the same for your web output, your HTML output, as it does for your tech output. And given that as your constraint, you should program it in a language which works best given the range of outputs that you're producing. If you're only producing print, then that's a different constraint from if you're producing print and web pages. So the numbering of equations, the numbering of theorems, the identifying of equations by symbolic names and referencing of those things, all these things have to work both in print and in HTML and on PDF. And if LaTeX is the only language you know and the only language you want to use and the only language that is acceptable to your peers and so forth, then you'll use it. But if your peers are web developers or people that use Python or Ruby or whatever else, then you'll use different systems. And it creates a problem in terms of making tech attractive to people from outside the community. I think I've said enough to now about the way I'm thinking. And in a nutshell, it's this: there are certain things that are central to tech. If we're going to have those things continue into this century, we want them to be central to tech for PDF, for print, and for interactive displays such as web browsers. And so we have to think about the things that are inessential and say, well, perhaps we should be changing some of them. So it makes perfect sense if I go back to LibreOffice being downloaded, if we're going to have a version of TeX that runs in the web browser, it makes perfect sense to use the web browser's FVG capabilities for the display. And it makes perfect sense to allow people to use JavaScript if they want to for processing the input stream. And some sort of holding on to the essentials and flexibility outside. And also this idea that LaTeX is finding lots of things really difficult, and in particular, producing a tagged PDF really difficult. And I think it comes down to this, that LaTeX doesn't intervene closely enough into putting the things on the horizontal list. And it can't. It's just sort of not in its capabilities. And the other thing is that it's trying to solve everything in a particular way, whereas the difficulty is that particularly the page breaks break things. The page break breaks the tagging that you want to do. And the way to solve that is not inside the TeX macros, but after the output has been done, to fix up all the stuff that's broken. To leave enough information so that you can close the tags that aren't closed. So when we go from blue back to black for the ink color, but the blue color spans from one page to the next, we put down the markers into the pages, but then after we've got the pages, we say, okay, well, we haven't closed the blue tag yet, so we'll close it at the end of this page, and we'll remember that, and when we go to the next page, we'll put in the blue tag. Now, the links that tag PDF require from one part of the page to the other have exactly the same feature there. So I'm going to try and persuade myself to stop talking. I'll even mute.
Jonathan, that was I found that inspiring. Thank you. I've made some notes, so I'll go through go through some of these, if I may. You said TeX. Am I right that you're using TeX and LaTeX interchangeably? You're not, or are you saying specifically LaTeX or TeX? I think it's the former.
I'm probably not being completely consistent. When I'm talking about the typesetting functionality, I will use the word TeX, because LaTeX has no typesetting functionality.
Okay. Yep.
It's not a typesetting program. It's something that provides inputs and works within a typesetting program. But it's TeX that breaks the paragraph into lines.
Okay.
So when I'm talking about macros, I will talk about TeX and LaTeX interchangeably. So TeX provides macros and LaTeX provides macros. And I view LaTeX as a collection of TeX macros that's particularly large and worthy of a name of itself.
Thank you. So while I've got my microphone on, so the color packet, I remember absolutely the color problem. I remember actually when the first time that David Carlisle was, well, I think is it the color package that he was announcing? He specifically said the problem was, opening, begin color and end color. It's very difficult because the pages are breaking and it forgets, right? So I remember there was a big meeting somewhere in Oxford, I think, where he talked about that. Generally, I find that your idea is interesting. I don't quite, there are cleverer people on this call than I am. But so what you're saying is we use the problems that we use TeX for what it's good at, maybe just, but then we use something else further down the line to do the line breaking and the page breaking, etc. Is that in a nutshell? Does that make sense?
the essence of it is that we take away from tech everything that's not strictly required for typesetting, and we take away from it its page breaking responsibility if we can. I mean, when I say take it away, make it an external thing. So you can use text page breaking if you want to, but make it a clean interface so you can put in a different page breaking system if you wanted to. So on the output end, you've got the page breaking. You keep the paragraph stuff, you keep the math stuff, you keep the table stuff, you keep the stuff related to hot fonts and hyphenation and I think that's probably most of it actually. And on the input end, you allow people to write tech macros if they want to use tech macros, but you don't make that a requirement. So you try and draw a line around the typesetting functionality in such a way that it can be used by different systems.
On that point, am I right that when, suppose we take one paragraph, I think you said that when tech, you've got a long paragraph, first tech expands all the macros, then when it comes to breaking lines, it's forgotten about that, it cuts into lines, then goes back to the next paragraph. Is that right?
Yeah, so the par command in tech says, stop what you're doing, take the current horizontal list and break it into lines. And when you're finished, pick up where you were before. But so as far as the macros are concerned, it issues the par command, and then it then it goes to bed, and then it wakes up in the morning, and there's a whole bunch of new stuff on the main horizontal list. So before the par, the main horizontal list has got a certain size, and then it issues the par command, and there's no macro processing after that command is done. And then the next command has a look, and it says, oh, Santa Claus has been. We've got more stuff on the main horizontal list.
Okay, thank you. Let me just quickly go through this because I made some notes. And right, the other thing is I always remember from the old days, I was thinking, you know how tech is cleverly takes a whole paragraph and optimizes it, right? To for example, if you have on the second line, you have a really bad long box, then, sorry, on the penultimate line, for example, of a 10-line paragraph, it can just add spaces automatically in the first line so that the last line looks okay, or the penultimate line looks okay, right? That's the clever optimization of the whole paragraph in one go, as opposed to breaking lines and then forgetting about it.
Yeah, if you like, it's a sort of psychic action at a distance. There's this big thing that's unbreakable in the last line, or in the middle of the paragraph. There's this big thing that's, you know, this enormous long name that can't be broken. Yeah. And somehow it manages to avoid breaking it.
Okay, so I remember thinking, wouldn't it be nice that optimization of the horizontal list could be done with the vertical list as well? So you have a chapter of 20 pages or 30 pages, as you were saying. If we had enough memory, take that whole chapter into memory and optimize that. So if you've got a really bad box on page 5, it's automatically done just like a paragraph. Does that make sense?
Yeah. So a lot of people talked about, or several people have talked about this, and there's no particular reason why it shouldn't be done.
Yeah,
I suspect that it probably is done on some commercial systems.
But
yeah, I'd like to interject here a comment
please.
on that, because Don Knuth and Michael Plass wrote a famous paper on the page breaking problem that appeared in Software Practice and Experience. And it's certainly listed in the textbook bibliography. So they addressed it. The issue was in the 1980s, memory was just too small to consider doing that. And it's quite a tough problem because unlike the breaking of paragraphs where you have little pieces called words that have spaces between them, With pages, you could have bigger blobs called figures and tables.
Mhm.
And there was an either late 90s or early 2000 thesis by a doctoral student in Germany, Stefan, and the name might be Wolf or Wolfsdale, I'm not remembering correctly, who looked in great depth about the multi-page page breaking problem. And it's extremely difficult. And finding good algorithms for it is probably still somewhat an unsolved problem.
Okay, thank you.
I also just wanted to inject two things here. The example of color being needed to be carried across page boundaries is important. There are two other things that haven't been mentioned. One is the current language you're typesetting in, because in multilingual documents, the hyphenation rules change when you change language. And the second one is the writing direction, because when you're typesetting Hebrew or Arabic, which are normally right to left languages, they have the peculiarity that when they have inserts of Roman text from, say, English, or they have digits, those are typeset from left to right. And so Hebrew and Arabic and general Semitic languages, except for Maltese, which is the only one written left to right, have this problem that you always have a mixed direction to deal with. And that has to be preserved across page boundaries, and it leads to puzzlement as to what do you do when you're in a word that is going in one direction but has to be hyphenated at the end of the page. And I'm sure there are policies for doing this, but they're not obvious to me.
I'll just pass. Carver, anyone else?
Okay.
I remember what I said. Yeah, what one can do is you can think of the document as being an XML document.
Yeah.
And then instead of producing the output pages as we normally do, a DVI or whatever, what we can do is you could put little markers in the XML document saying, there's a line break here. There's a page break. There's a line break and a page break here. We can put those sorts of markers inside the XML document. And that makes what's going on a lot clearer. So we have the flow of text and we keep the XML document, but we annotate it in various ways, saying there's a line break in the middle of this word.
Sorry, who puts how does that mark come in? Is that automatically or is that an explicit break?
That has to be put in by the typesetting system. So instead of the typesetting system, instead of XML coming in and lines of a paragraph coming out, broken lines of a paragraph, you simply take the XML and add to it additional information, such as there's a line break in the middle of this word at this location. Because the difficult thing is deciding where to put the breaks. That's really what it's about. And adjusting the spaces so the breaks occur where they should sort of follows more or less automatically. So if we think of it in terms of we're taking an XML document and we're just putting a vertical pipe wherever there's a line break, that's a good approximation to what typesetting is doing. It's making decisions where to put things, where to break things. And if you do that, then what you're doing is you've still got your abstract syntax tree, you've still got your document object model, but the breaks that are taking place are clearly taking place inside the document object model. And then you know what to do when you break it into pages in that way. And in a certain sense, a lot of the complications that the LaTeX people have to do their tagging PDF is they have to produce a document object model in order to know what partial tags what mid-element tags they need to close and reopen again. And this approximately corresponds, if you know about these things, there's two approaches to parsing XML. The one is to form a document object model, and the other is to produce a serialization of that model. And what they're trying to do is to produce a document object model from the input stream the hard way, using TeX macros. If the typesetting systems took as an input an XML document and produced as an output the XML document with some additional information saying these are where the line breaks are, these are where the page breaks are, then from that point of view, from that moment on, producing the tag PDF becomes really easy. So there, that is, I think, why they're having such a hard job of it.
Okay, so you have an XML source, supposing whatever, it goes through either TeX and it's converted on the fly into TeX, or it goes through another program that does that optimization and doesn't do anything except puts markers saying this is where the line breaks are, in my opinion, right?
Yeah.
And then it becomes easy to put those and space it out if it's justified, etc. Another program can just put them cut the paragraphs up.
Yeah.
Okay.
Yeah, and you don't forget, you have to also include the case where the display end is not allowed to insert line breaks, such as computer input and output. And in modern HTML pages with cascading style sheets, the way that's usually happened is you wrap the computer input and output in an environment that says, I can't break lines here, but I can be scrolled horizontally. And then even if the web page is narrow, the user gets a little bar at the bottom of the display suggesting that you're only seeing part of what's here, and you can scroll the bar to the right or left to see more. So both those cases of explicit breaks and also explicit non-breaks have to be dealt with.
But that should be okay. That's not difficult, I think, right? Conceptually, because you've got a begin computer, end computer, and you
exactly.
know you can't break that. Okay.
But it's something that has to be, even though it might be part of the input markup, saying here's a block of computer input and output, it has to carry through to the display routine saying that this piece of text has to be handled specially. You're not allowed to do line wrapping or change the spacing.
Okay, the penalties for breaking, for page breaks are a sort of separate matter that I haven't considered that much. I think Carver's done us all a great service by asking his sort of clarifying questions, and it's not necessary for a typesetting. The purpose of the typesetting system is there's two sides to it. The one requires, so to speak, thought, or clever algorithms and Knuth and Plas, which is deciding where to put the breaks. The second part is recording that information and taking the administrative consequences. And the administrative consequence that TeX takes, because it's a sort of stream process, a sort of pipeline, is to produce a bit of something that goes into a DVI, an HBox. But the information could simply be recorded to be placed back into the XML file that we started with, if that's what's the appropriate thing to do. The important thing is deciding where the page break should go. So another way of looking at it is, suppose you've got a book that's already been typeset, and you want to typeset it with TeX with exactly the same line breaks. Well, you produce an XML file with the line breaks marked in it, wouldn't you? And those line breaks would say break here, break here, break here. And in a certain sense, what you're doing is you're you can record that information into the XML file to say to TeX, well, you've calculated this already, there's no need to recalculate it.
And a good example of that requirement of maintaining the line breaks of an original document appear in both legal texts as well as in religious texts, where the line breaking cannot be changed. It's part of the original prescription of the law or the scriptures. And yet you may be resetting this document with more modern fonts for different display devices and so on. So I've actually seen discussion of books where they were reset in a different font, but they had to keep the same line breaks. And this, of course, causes problems with suboptimal spacing and so on, but it can be an important consideration.
I have a little story that is related to this, which is that it's something like a Chinese have a tea ceremony, which is a semi-religious sort of thing with sort of large amount of formality, and it's sort of naturalness and beauty. And the tea master was asking the carpenter to hang a basket or something for flowers, and the master was, you know, somewhere away, and the carpenter was moving the basket. Do you want it here? 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 And the tea master said, you know, guiding him, and said, this is where you want it. And then the carpenter put an X on the wall to indicate where he should put the basket. Now, have I got it right? Anyway, to test the tea master, the carpenter pretended that he couldn't see the mark, that he'd lost his mark, and asked the tea master to go through the whole process again. And the tea master chose exactly the same point as before. So when we've typeset it once, those line breaks don't need to change unless the content changes. So we don't have to store the output. We can create that output, that PDF output, whenever we want. All we need to store is where do those breaks go. If you imagine the thing perfectly typeset, we have to record the information that tells us what that perfect typesetting is. And that means that the first line of chapter 14 of the TeX book ends on the word words, and then it's example, comma, and then it's wide, comma, and then it's these. So I can read down the right-hand column, and that tells me exactly where the line breaks occur. And if I want to repaginate it with exactly the same beautiful typesetting, all I have to do is say these are the words that appear on the end of the right-hand column.
A hidden sort of one possible advantage is this: supposing you haven't got the original typeface, but you got a very close typeface, you can still typeset it with exactly the same. If you put it through TeX, because the metrics are different, so it's going to give you different pagination. But this way, you know you're going to get the same page breaks, etc., with tiny changes in space, for example.
Yeah.
Okay.
Yeah.
Oh, it makes sense to split the two things into two. I mean, a lot of problems with TeX is that it's doing so many things on the fly, that in the palate and its mouth, or I forget that, whichever, or in the stomach, and it has to sort of handle those all the time. That's the complexity of TeX, isn't it?
Yeah. Or if you're using, never mind fonts, if you're using a style file and there's some sort of differences in the third decimal point regarding the glue spaces, or the penalties. I've sort of given a fairly big picture, but in terms of going forward, what I'd like to do is actually start with really simple stuff so that people can see it working. And so I can actually solve real problems such as the color problem. And for the Open University, I did some books where you had large amounts of examples that had to have a colored background on them. And that's fine if they don't cross the page boundary. And I had to use some very clever macros that I don't understand involving output routines from Donald Arsenault that allowed those colored backgrounds to split automatically. You didn't have to say, oh, it's going to split here. It would choose the split according to where it chose the split, and it would give you the backgrounds exactly right. And those sorts of things are really hard if you use TeX in the traditional way. And you have to think about what problems TeX was designed to solve and what problems do we have to solve now. And I'd say the biggest single problem we have to solve is having HTML and PDF outputs from the same input. That's the single biggest problem.
I like the idea. Firstly, there are some of the, you know, the sort of the older guys, if you like, my age in TeX, who would think that changing it, basically TeX is TeX and it's brilliant, and any change is sacrilege. I think we need to, you know, your ideas are, you know, more liberal, if you like, and I agree with that. You know, let's use what TeX is good for and recognize it. It's over 40 years old, so you know we don't have those memory problems, etc. So that's one thing. One specific query is this, Jonathan. TeX is very good and has this very complicated way of processing floats. Do you think that's not such a complicated problem? Supposing we had another mechanism to create these floats, floating figures, etc. Could that be something that that TeX is really good at, and we'd be in trouble if we use something else? What do you think?
I think that Martin Ruker's probably got the best answer there, which is I'm pretty sure that Hint handles floats.
Okay.
And even if it's not the best solution, it's a divide and conquer. There's two problems, and floats is one problem, and the vertical list is another problem. So the question of high quality book typography is an important one.
Mm-hmm. Mm-hmm.
But I don't think it will be the first problem to be solved. I think perhaps the first problem to be solved would be producing simple tagged PDFs that are reliable.
Mm-hmm.
Because it's an easy problem. It's sort of a warm-up exercise. I've been writing mathematics up, and I find it impossible now to deal with the general case of a calculation without first doing some warm-up exercises. And to refactor TeX so that the LaTeX contribution doesn't have to be written using TeX macros is not something to be tackled immediately. It requires warm-up exercises, and it requires experience from that.
It's on the subject of floats. It's worth remembering that these are really just a form of cross-reference. You want to mention in the text that there's a figure or a table that has something of interest in it, but you, for typographic reasons, you perhaps don't have space in the current page. Now, in terms of, say, a screen reader or an HTML display, you could simply leave that figure or table completely out of the stream and replace it by a link. And then the user gets to choose, do I want to see the table or not? And so in some sense, in HTML, floats are an easy problem because they're just a hypertext link to somewhere else that you can then come back to. But of course, it's a huge problem
right where they're mentioned.
For pagination. I'm getting the floats near the point of reference, and
no, I'm specifically, I'm specifically thinking. Sorry to interrupt. I'm specifically thinking of books, if you like, floats in books. That's in paginated material.
Yeah.
Yes, Chris.
From a technical point of view, from the way TeX does things, floats are no different than footnotes, except But practically they're different. There is a difference, which is that floats are unbreakable, whereas footnotes can be broken. So it's possible to start a footnote on one page and continue it on the next one.
Right.
And in
On
the
that
humanities,
point,
that sort of thing happens.
okay, that's a very good example. That, you know, TeX is one of the few things that that actually nicely breaks a footnote across pages. If we are not using, is that a okay problem if we are not using TeX in the vertical list? How do we do that? How do you now?
You use TeX algorithms. That's all. That's the solution. You use TeX algorithms. In principle, you could probably refactor TeX into 3 parts. One of which does the LaTeX part, one of which does the page makeup part, and one of which does the sort of vertical list stuff. And each of those 3 parts will have a defined interface between them. And out of laziness, each of them will be implemented using using the TeX program, but each will be using a different subset of the TeX program. And you'd have to sort of make some changes to glue everything together. So that's a bit like having a web app, which originally runs on one machine, but then you say, oh, we need a separate server for the database, and we need a third server for the database, and we need a server to do the templates. And so in the end, you find that your very popular dynamic website is in fact being served by half a dozen machines, and that each request for a web page might touch a dozen machines. That happens now. So you can imagine using TeX to do this part of this process, and then with an interface talking to another thing. So the creation of the final PDF comes from a box, shipping out a box, and there's no reason why you shouldn't put an interface there saying, at this point you ship out a box, and at this point you take a shipped out box and you turn it into a PDF if that's what you want to do. And at that interface, approximately, this is where the back end of hint could be used instead. That's very approximately, but instead of thinking of it as a monolith, because TeX was a big program and now it's a small program, which means that we can actually give it a bit more room. We can say, okay, well, here's 5 megabytes for doing this, and 5 megabytes for doing this, and 10 megabytes for doing this. So we don't have to have everything sort of sitting in one pool, sharing the same memory, sharing the same CPU. And we can have a separation of concerns with a clear interface between the parts.
So quick point, one of the things, I mean, so many good things about TeX. One of them, and one of the important points when Knut wrote it, was that if you run it on one machine, then run it on another machine, you will get exactly the same page breaks and line breaks.
Yeah.
So that's something we are potentially losing here, right? Because
yeah.
But then, how important is that, and how, that's another question.
I think it's really important, just as it's really important that a meter is always a meter. But and at one time I was quite a bit of a Knuth loyalist, and that would be one of the things that I would hold to, is saying this is something we don't want to lose, and we don't want to lose it. At the same time, because it's valuable, it's something we want to give to other communities. So if that reproducibility existed in other areas, that would be great. I mean, operating systems, people are sort of working really hard to try and make, as a practical matter, operating systems reproducible. And that's, if you like, part of what virtualization and virtual machines and emulators are all about, is trying to get that reproducibility. It's one of the things, and that's also what version control is all about. We've got reproducibility on files now, largely through Git, and I think that's wonderful. So yeah, that's something we don't want to lose. at least I'd be happy to have a proof of concept that lost it, but I'd hate to sort of.
I mean, you
Go
could
large
still
scale
have,
production.
even if you have 2 or 3 different bits doing different things, each one can be standardized and say, I used version this of that.
Yeah.
You know, you can still, I'm guessing you can still do that. But I just find it refreshing that we are sort of, we're, you know, up to now, the tech program has been, you know, hasn't changed for decades, but we're, you know, we shouldn't be constrained by that. Nothing is forever. But it's an amazing program. Let's use the good parts and move on.
I think that Tectonic is going in a similar direction to myself. Peter Williams.
Mm-hmm.
I was very impressed by his keynote at the TUG conference this year, and he's sort of approaching it from a different point of view, simply because he's a different person, not because there's a conflict or disagreement here. It's just he's looking at it from a different point of view. But if we go back to the late 70s, early 80s, the whole environment was different. And also Knuth is something of a unique person. Just as, for example, Linus Torvalds is something of a unique person. And quite how we sort of find our heroes today is another question. I'll say it again, even though it may embarrass, but the archive is a tremendous thing, and it has a momentum and a reputation amongst the STEM community in the same way as the AMS had for tech. I was a member of the AMS, and it really is a powerful organization in terms of the membership it has. David, you want to talk? No?
Can I just say, have you a slight segue, but making good-looking PDFs? Are you familiar with the W3C CSS paged media?
No,
so, right.
I'm not.
Basically, the idea is to make it's called I believe CSS paged media. It's a way of making pages using CSS. So HTML plus CSS to make pages. Sorry, I haven't got. If you Google it, you'll find it. There's also in parallel, there's a group that are trying to. I mean, I've always said in specific, especially in STEM publishing, that what you want is XML first. Everything should become XML, and from that you press the button, a bit like you were saying, Jonathan. Everything comes out, whether it goes through TeX or CSS or whatever. It goes into. Sorry, I was just finding. Yeah, so you get the output that you want. There is another group called the Cocoa Foundation, and there's a thing called Page.js. So what they're trying to do is similar, from what I understand, to CSS paged media, but starting from HTML. They're saying, why the heck are we messing about this XML business? The web is the future, so let's just use HTML. Not clear what kind of HTML or how strict it is, but use JavaScript and other CSS, etc., to make that into pages. So I mean, my view, you might expect, is what I'm saying is we've got an engine already, we've got tech and tech variations. That's the way to make pages, but there's a sort of slight disagreement there. So that it's quite active at the moment.
Thank you very much for that, Carve. I think the paged.js, I think I'd seen.
Yeah.
In term, Don Knuth had a lot of contact with traditional typographers. I think that today the analog will be to have contact with people that do web pages and people that do information architecture.
Yeah.
Information architecture is really important. And it used to be that, Aldus Manutius, Venetian publishing, scientific publishing, all that sort of thing, was the information architecture. If you had the scientific handbook, that's information architecture. Samuel Johnson's dictionary, that's information architecture. And where is information architecture now? It's in the things that are delivered by websites. Whether it's government information or political organizations or the World Cup, what's the word? The current state of play in the World Cup, that's information architecture. And so those are the people that the tech community needs to have more contact with. If the value that tech has is a very high value, it's not becomes available to these people. I mean, in a certain sense, our job is not to tell these people how to do things, but to come bearing gifts, which takes us to Christmas, doesn't it?
Talking about the Bible, if I may, there was, okay, what I'm going to do just for now, I don't know if any of you are on Mastodon, but a few people have got, because of Twitter, we've gone onto Mastodon, and there was a little discussion there, and I put the link if you want to have a look later. But people in publishing, and I was saying we should use XML first, and why don't publishers publish the XML, etc. And actually Adam Hyde from somewhere there from Cocoa Foundation, who I know well, he commented there as well. But the thing about the Bible is this: one of the things was saying, okay, we've got HTML, we've got PDF, etc. We should get away from page numbers. Because if that is not your absolute record or version of record, it's we shouldn't be referring to page 59, because where is page 59 in the HTML? So the suggestion was, I mean, I was thinking let's do paragraph numbers, and basically like the legal the sort of legal people, lawyers use it. And also the Bible, which has
chapter and verse.
Christian chapter and verse, exactly. And apparently the chapter verse, is it the verse? That was the origin of the paragraph, according to someone, not sure. But anyway, that's how it was broken up. But it makes sense now to refer to chunks like paragraphs, which are the same, whichever format you're reading, rather than pages, because that page is now holding us back.
I think pages are useful, but we shouldn't put too much reliance on them.
Yeah, but the problem is, if I refer to something, page so-and-so of this article, then that is only available through the PDF for me. And if I'm reading on HTML, or if I'm using the XML with some sort of machine reading, I say, get me this chunk. Right? I can grab that, and I know that was referred to. I have no idea if it's pages unless I put the pages back into XML somehow, and that's not a good thing.
I came across a mathematics website called Stacks, and it's evolved into being a fairly comprehensive textbook on algebraic geometry. And it's available as very nice HTML and also PDF, and they're linked to each other. And many items have a unique URL that's persistent. And it reminds me very much of Dennis Mueller's talk about semantic tech. and it's related, of course, to what you were saying, but the ability to refer to a precise part of a document. One of the things that impressed me with GitHub when I learned about it was that it puts up where you can create a URL that references a specific range of lines in a file. So you can create a URL and the hash is lines 37 to 43. And when you visit that, you're centered on that part of the file and it's highlighted.
Okay.
And I thought that was very, very impressive. I think that one of the big things that is happening nowadays in sort of media generally, is that the stuff that the programmers, the geeks, have developed for their own purposes, for their own efficiency of communication, have escaped the zoo and gone into fairly general use. Even the hashtag is now a sort of cliche in media. People don't say what's a hashtag; they know what a hashtag is, and the what's the word? I mean, books depend upon a literate a class that has literacy, a social group that has literacy, and in a sense, they must which was largely, I think, the monastics, and that sort of literacy, it so to speak informed the printed book in many ways, and digital literacy and digital sort of communication is going in a similar sort of way that the people that are getting quite skilled, the people who are technical in some sense are actually very, very skilled in creating and disseminating these skills that other people are taking for granted. So it's now not a big deal that you can write your own letters with your word processor. You don't need to go on a course to learn how to use a word processor. Whereas I think there was a time when you had to go on a course before we could use WordPerfect. Maybe I'm exaggerating.
Yeah, I'd like to toss in a comment on the pagination issue. When Don Knuth wrote his famous book series, which is still in progress, The Art of Computer Programming, I think we've reached volume 4 or 5 now, but there have been multiple editions of these. But because these books are referred to elsewhere, it's really critical that when someone says on page 27 of volume 2, Don said that blah, 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 that cannot be broken. And you have no control over the other documents. So when he had to introduce corrections or add a reference or two or expand the description, he was faced with the problem, well, I can't change the page breaking.
Wow.
So what he would do on specific pages, if he needed a little bit more material, he would reset that page in a slightly smaller font in order to make it fit, because it would otherwise invalidate the index. And it was also important in the days of hot metal typesetting, the publisher maintained the plates, and any change in pagination would require completely resetting the book at great cost. Whereas redoing a single page plate for a book as important as that book series was economically feasible.
Brilliant, brilliant. Of course, in those days, that was, when you started writing that, you only had books. You had this argument didn't come up. But so for legacy stuff, I guess we're stuck with those pages. But going forward, we can just say paragraphs. But you make a very interesting point, Nelson, about the index. The index is another thing. Right now, when an indexer indexes, still they are indexing, most indexers are indexing page by page. So basically the book is finished, the galley goes to them, and you can't change it afterwards. There is you can do embedded indexes where you rerun and it'll rerun the index as a TeX would do, but most of them are not that way. However, what I'm thinking is if the indexers think in terms of paragraphs as well, I was thinking about today, they just refer to that paragraph. Then you don't have the problem. And in fact, when we print the book, in that case, we should not have page numbers. at all, because then, you know, that it doesn't mean anything. Page numbers don't mean anything. And thank you, Christopher, for that link. I didn't know about this JASSS, which is an online journal that has paragraph numbers. I downloaded the PDF, but you can see the PDF is actually generated from the HTML. It's not
right. It's definitely HTML first.
Exactly. Yeah. It's not the most beautiful.
It is not
page. However, but it doesn't have page numbers. You know, that the only way to get rid of that reference to page numbers is to get rid of page numbers entirely. But of course, going back for older, if there's a reference somewhere, we're stuck with that.
I'm writing up some mathematics, and unusually perhaps I'm doing it on pieces of paper, and each piece of paper's got sort of 10 small paragraphs on it. I use small pieces of paper and I number the paragraphs. And I find that's really, really effective, and I can do cross-referencing this stuff. And when I have conversations with somebody over Zoom, I can send the scans of these things, and I can say, well, paragraph 1, paragraph 2, and that person can say, what do you mean in this? It makes communication very, very easy, because it's like pointing to a particular part of the document.
Yep.
The finger is a very, very important device of communication.
I'll raise another example here where page numbers have significance. Journals traditionally were published in annual volumes, sometimes multiple volumes per year, and sometimes for postal reasons, the volumes were split into issues, monthly, bi-monthly, and so on. And then within each issue, the page numbers increase sequentially. Now, as we've moved to electronic publication, a number of journals, notably both Springer and Elsevier, for some, but not yet all of their journals, they've gone to article numbering rather than page numbering. Now, unfortunately, what both of those publishers have done is essentially assign a random number to the article number. There are some publishers which actually use a sequential article number, 1, 2, 3, 4, and so on. But say in the physics literature, I find article numbers are 6 and 8 digits long. Now, here's the following problem. If a person like me wants to document all of the papers that appear in a particular journal, if there are page numbers, I can do a page gap analysis and detect missing pages. And on a number of occasions, this has turned up errors at the publisher website where papers have simply been lost. And I've reported it to them, and eventually they get found and put back in. But with random article numbering, this has gone out the window. It is now impossible to know whether an article has disappeared. And so if a publisher computer staff make a mistake in putting web links on for the articles in a given issue, a paper that you think has been published effectively has not been, because there's no link to it. Even if it's sitting there on the web server, but there's just no link to it, it cannot be found. And it doesn't exist, and there's no reference to it anywhere. And I think this is of considerable concern, because I see this frequently happening in the journals that have switched to article numbering. Some of them have the practice that they send out announcements when an issue is complete. Others simply keep adding articles to the issue. So again, if you're the bibliographer trying to track that journal, it becomes very difficult to tell without page numbers if you've actually got everything in that issue. And the page gap analysis can help you discover, oh, there was 5 more articles published when I took the snapshot of the web page. After I took the snapshot, and so I can detect those and find them. But with random article numbering, that's completely impossible. And I think this ought to be a concern for all of us, because in the absence of paper copies, which are effectively an obvious record of the publication, electronic publication is a lot more ephemeral, and things can disappear for various reasons: mistakes, censorship, articles withdrawn, and so on.
I can't see what the random number doesn't make sense to me. There must be something.
No, but it's a common practice, certainly in the physics literature.
Wow, I didn't know that. What I have come across is is that pages numbered each. You've got an article, it's the volume number or something, and then each article starts from 1 again, because they don't want to put it together, you know.
Yeah, exactly. And that's typically what the journals that do article numbering use. Every article starts at page 1.
Exactly.
But the examples they give of referencing that article just show a volume, an issue, and an article number with no mention of a page number.
Wow.
But of course, then that doesn't tell you how big the article is. And sometimes that's of interest. You might be much more interested in a 100-page article on the subject you're interested in than a half-page one that was a minor comment.
I think we're getting into areas of library management, information management, and that sort of, which are all very important, and perhaps a meeting sometime on journal publishing. And I really liked, Chris, your contribution of the journal with numbered paragraphs. The handling of all this sort of, I don't know what you call it, critical apparatus, references to things, is it's sort of information management, isn't it?
Yep. Well, this has been a great meeting. Thank you, Jonathan. It's really a lot of food for thought. A lot of food for thought there, and some ideas to expand on.
Well, I'm glad that I said something that was sensible.
You always do.
I like this idea of annotating and something like XML about where the page breaks are. That I think would be pretty they want to use HTML versions in a way that someone who's reading the PDF would be able to identify them. So knowing that there's a picture on page 5, like that, it's really nice to be able to embed that information into the HTML.
If I'm visually impaired, if I'm blind, and I know what the page numbers are, then I can, you know, if I'm reading the XML, I actually do need to know the page numbers, just so I can say to somebody else, this is where to look. You know, I've got this problem on page 6.
Even if it's not the best way to identify things, it's a common way.
It's better than having no way.
Yeah. Yeah, I was wondering if the JATS archive format might be appropriate actually for representing the post page breaking and layout formatting. The JATS archive is supposed to represent the item as it is, if I understand correctly.
I don't know if JATS is going to support that, or you'd have to extend it.
It would have to be extended.
But that's something we do anyway. We use JATS, and we put processing instructions in JATS so that when we go from that to page, we know where to, you know, that's the sort of information we're talking about. So you can put comments or processing instructions for your own use. But then that's outside, it's not part of JATS. That's the problem.
Varieties of JATS.
Okay.
Which of the 3 versions of JATS?
I don't know offhand. I think we use the latest version, but of course, as you say, there's good JATS and bad JATS. You can code it nicely, or you can, for example, in references, you can put you can put mixed citation, which means you can put any old rubbish in there, and it says fine. So there are good and bad ways of using JATS. I
think we should sort of wind up now. I'm very grateful for everybody. It's been a good conversation. I'm thinking perhaps in the new year, something on journals, information management, JATS, that sort of thing. And I'm not the right person to bring about such a discussion, but if anybody else wants to have a go or suggest speakers or topics, that would be really helpful. And I think digital humanities is something well worth taking a good look at. And part of that is that Patrick Smythe, who's speaking next month at the STEM meeting, did a PhD in digital humanities. And it's on the subject of accessibility. And the text encoding initiative and XML are very strong in at least part of digital humanities. Whereas the representation of things is not that important, except they want to encode important works. So Shakespeare folios, you'd like to encode them in XML. And if you have a document where some of the stuff is bold, you want to encode that it's bold, because that's part of the document. It's part of the, even though it might have a meaning. So I'll stop at that point, and anybody else can make a closing comment if they want to, and then I'll close the meeting. Oh, Merry Christmas if I don't see you before.
So are we meeting again before January, or are you putting things on hold?
No, there are slots, and I'll see what I can do to fill them.
Okay.
The website is the canonical place to go for the news as to what's going on.
Thank you, Jonathan. Thank you, everyone. Great meeting.
Thank you very much.
Thank you.
Thanks.